Let's solve this fourth-degree polynomial equation by recognizing a special pattern. This equation has a special structure that resembles the binomial theorem expansion. The first step is to recognize that the left side follows a binomial pattern. Notice the coefficients: 1, -4, 6, -4, and 1. These are the binomial coefficients from Pascal's triangle with alternating signs. This matches the expansion of x minus 1 to the fourth power. Here's Pascal's triangle showing how the coefficients 1, 4, 6, 4, 1 appear in the fourth row. Now we can rewrite our equation using this binomial form. Our original equation is x to the fourth minus 4x cubed plus 6x squared minus 4x plus 1 equals 16. This simplifies beautifully to x minus 1 to the fourth power equals 16. We've transformed a complicated polynomial into a much simpler exponential equation. To solve for x, we need to take the fourth root of both sides. Starting with x minus 1 to the fourth equals 16. We take the fourth root of both sides. This gives us the absolute value of x minus 1 equals the fourth root of 16. The fourth root of 16 equals the fourth root of 2 to the fourth, which is 2. So we have absolute value of x minus 1 equals 2. An absolute value equation gives us two cases to consider. The absolute value of x minus 1 equals 2 means two possibilities. Case 1, x minus 1 equals positive 2. When x minus 1 equals 2, we get x equals 3. Case 2, x minus 1 equals negative 2. When x minus 1 equals negative 2, we get x equals negative 1. Our two solutions are x equals negative 1 and x equals 3 on the number line. Let's verify both solutions work in the original equation. First, let's check x equals 3. Substituting 3 into the original equation, 3 to the fourth minus 4 times 3 cubed plus 6 times 3 squared minus 4 times 3 plus 1. This equals 81 minus 108 plus 54 minus 12 plus 1, which equals 16. It works! Now let's check x equals negative 1. Substituting negative 1 to the fourth minus 4 times negative 1 cubed plus 6 times negative 1 squared minus 4 times negative 1 plus 1. This equals 1 plus 4 plus 6 plus 4 plus 1, which equals 16. This also works. Both solutions check out perfectly in the original equation. Let's state our final answer clearly. The solution set is x equals negative 1 or x equals 3. Both values are real numbers that satisfy the original fourth-degree polynomial equation. The key insight was recognizing the binomial pattern x minus 1 to the fourth, which saved us from tedious polynomial factoring.